Hey students, in this video I'm going to explain how to do the notes 4.1. These are about triangle inequality and also ordering angles and sides and comparing two triangles with each other using inequality. So the first part is just understanding the rule about a triangle. A triangle exists if the sum of the two smaller sides is larger than the third side. So to summarize that, it's just practically saying you are going to add the two smallest sides and then they should be greater than the biggest number. So for example, this number one is already done for you. They're giving you 3 side lengths and you look for the biggest number, which in this case was 24. And you're going to use the other 2 side lengths to add those and get a sum. So the 25 is the sum, the 24 is the biggest number that you have from the side lengths, and then you compare. So 25 is bigger than 24, so this is yes. This triangle will be created. Let's do number 2, just to kind of go over an example again. The biggest number here is 7, so we're going to do the sum of 3 plus 3 and check if it's greater than 7. 3 plus 3 is 6, and 6 is not greater than 7, so no. This is not going to create a triangle. The other examples below are just the same thing. Add the two smallest sides, check if it's greater than the biggest number, and just practice on that. The next part after you practice that, it's understanding what if you're only given 2 sides. There is a method to find the third side, and that is writing a statement, mathematical statement that says what is the difference between the 2 numbers given and what is the sum of the 2 numbers given. And you write it in this notation saying that this is your smallest number, this is your highest number, and any number in between that will make this true. Notice that these are not equal to, so if you get the exact same number, it's not correct. It has to be a number between the smallest to the biggest. So here's an example already done. 14 and 22 were given. So we're going to subtract 22 minus 14, that's 8. And that goes here. This is the difference. And then you're going to add 22 plus 14, and that's 36. And that's here, 36. So any number from 8 to 36 could be the third side for that triangle. If it's less than 8, then it's not going to be true. So kind of like going back to this, you're going to get a no. If it's higher than 36, same thing, you're going to get a no. If you have exactly 8, it's still a no because it's not equal to 8. And then same thing with 36, it's a no if you get 36 for the sum because it's not less than 36. So let's now do an example of how this applies. So practice these, finding the sum and difference for those, and writing the statement of the 2 numbers that you get. And this is where you apply it. You're going to be asked, given the 2 lengths, check all the possible lengths of the third side. So out of all these, which ones could be a third side to this triangle? So we have 15 and 27. We're going to do 27 minus 15 and 27 plus 15. 27 minus 15 will give you 12. 27 plus 15 gives you 42. So you're going to have any number from 12 to 42. Any number from 12 to 42 will make this true. So you look at 34. 34 is part of it, part of that number. 12 is 13, 14, 15, 16, all the way to 42. So any number from 12 to 42 will be true. 12 is here. 12 is not going to be an answer because 12 is not less than 12. So no. 29 is part of that 18 is also part of that. 43 is bigger than 42, so that's a no because it has to be less than 42. So these three values, 34, 29, and 18, could be the measure of the third side. All right, practice this one and make sure you carefully check which ones are part of the answers. For this other part inside the booklet, we have a summary of the relationships between the sides and the angles of a triangle. So the rule states that the smallest angle is always opposite of the shortest side. So look for the smallest side, and right across that will be the smallest angle. Same thing with the largest angle. It will be opposite of the largest side. So an example here, we'll be looking at this example of ABC, triangle ABC, and order the angles from least to greatest. So notice we don't have angles given to us, but we can calculate which one is the least, the smallest, based on the side lengths. So you look at the numbers, you have 10, 13, and 7, and if you order these in least to greatest, you're going to have 7, followed by 10, followed by 13. So in this order, we're going to write the angles that are across from each side length. So first, the side length of 7, and right across from that is angle A. So we're going to put angle A as the smallest angle. After that is whatever's across 10. So this is the side length, and right across that is letter C. So that's angle C. And then the next one is 13, so angle B. And that's it. That's how you can reorder the angles based on the given side lengths. So here's an example done with color coordination. You can highlight the side length and the angle across, side length, angle across, and then side length and angle across. And then if you order them from least to greatest, you just look for the smallest number, which is 17. So across for them is M, followed by 20. So across from that is P, and followed by 24. So across from that is N. So let's try number 18 and see. Well, actually, try number 18 on your own. Let's do number 19 here on the video. This one, it's saying to do now greatest to least. So it's the same thing that we did here, but since this is least to greatest, greatest to least will be the opposite direction. So just kind of know how to look at your numbers. Because we're starting with the greatest, we're going to look at the biggest number, which here it will be 11, followed by the next biggest number, which is 9. The smaller version of that, and then 8. 8 is the smallest side length. So this, if you look right across 11, you have angle C. Right across 9, you have angle B. And right across 8, you have angle D. So this is the order from greatest to least. So try this example following that. Here is the next part, which is reversing. You are giving the angle, so you can find which side is the biggest, but you do need all three angles to compare. The twist to this is understanding that that third angle is not given for a reason for you to calculate it. So for example, here, we know that all of these sides add up to 180. We're going to add 42 plus 103. That gives you 145. And we're going to subtract that from 180. So that gives you the angle of 35. So this right here is 35 degrees. Now that we have all three angles, once again, you apply that the smallest angle is across the smallest side length. They do want this ordered from least to greatest, so we're going to do the smallest angle leads to the smallest side length, which is ED. And then the next one will be 42, which is across DF. And then the last one will be across 103, which is EF. So that's how we can order the side lengths, even though they're not given to us. We can use the angles to help us with that. So here's an example done, color coordinated. Same thing, we color the side length and color the angle that goes with it. So the corresponding angle, green with green, purple with purple, and pink with pink. And then you look at what do they want? They want least to greatest or greatest to least. This example wanted least to greatest. So we need to look at that third angle. The 92 was not given. We had to calculate it. We add the two angles that are given and then subtract that from 180, and that's how you get that third angle. Now that you have all three angles, you look at the smallest because they want least to greatest. The smallest will be 31, and right across that you have KL. So that's the first side length, followed by 57, and right across that is JK. And then the last will be the biggest number, 92. Across from that is JL. So that's how you will order from least to greatest. Let's try the next example with greatest to least. So we, again, don't have this third angle. Let's quickly add these. And then whatever answer we get, we're going to subtract from 180. So 82 and 54, that's 136. And then that will give us 44. So this angle right here is 44 degrees. And in order to put it from greatest to least, we're going to look at the biggest angle. The biggest angle here is 82. And right across from that is XZ. Followed by the next, the middle one, which will be 54. And across from that is YZ. Then the last one is 44. Right across from that is YX. All right, so that's how you will order these side lengths. All right, the last part of the notes was understanding how to use inequalities to compare two triangles. So the rules were stating that if you have an angle and it's greater than the corresponding angle, that must mean that the side length that is across that angle corresponds the same way. So this one was the biggest. That means this is the longest side. So this is greater than that, just like this side length is greater than that side length. This is the opposite. If you are given the side length and they're telling you this side length is longer than this side length, then we're going to assume that the angles are the same thing. If this is the biggest, then this is smaller. So this is greater than that, just like the side length is greater than that. So here's a couple of examples of how to apply that. The first example is showing, with color coordination, if you like, is identifying what they're giving you. They're telling you KL. This is KL. They're wanting you to compare it to PM. PM's right here. You don't know the side length, but you do know the angle across from it. So the angle across from KL is 79 degrees. The angle across from PM is 74 degrees. If we write those side by side, we can say that 79 is greater than 74, so therefore KL will be greater than PM. So if we try an example together, let's look at this one, AD. AD is this angle, this side length, and right across from that it's 59 degrees. Then you have comparing with BC. BC is right here, and across from that is 65. Then you compare these two. 59 is smaller or less than 65, so we're going to say that AD is less than BC. All right, let's try the next one over here. This one is saying WX and XY. So if you look across WX, you have the angle 53. And if you look across XY, this was missing. So we have to do the calculations that we did previously where you add the two angles that are given and then the answer is subtracted from 180, and that's how you get that missing angle. So the angle across from XY is 55. If you put these side by side, 53 is less than 55. Therefore, the answer is WX is less than XY. Let's try an example together. So PQ right here is across that angle, which we don't have. And then PS, this side, is across that angle, which is 83. So this angle, we don't have it. And if you look at the analysis of this, the annotations are saying this angle's here, but not that one. But together, they form a line, which means together, they add up to 180. So all we have to do is 180 minus 83, and that should give you the answer, which is, in this case, 97. So now we're looking at 97 degrees compared to 83. This angle right here is 97. And 97 is bigger than 83, so therefore PQ is bigger than PS. All right, let's try this one right here. It's talking about measure of angle D, which is right there, compared to measure of angle H, right here. You look right across, and measure of angle D is across side length EF, so that's 35 for that one. And then measure of angle H is across 33. 33 will be the measure for that side length. If you compare these, 35 is greater than 33, so therefore the angle of D is greater than angle H. Let's try this example on number 6. We have measure of angle A. So this angle across from that is 18. Angle E across from that is 18.5. If you compare these two, 18 is less than 18.5. So therefore the angle A is less than E. Last part is the combination of 3 letters forming an angle. So I highlighted that just so you could see it, how 3SQ creates an angle. I'm sorry, RSQ creates an angle. RSQ, follow this pink highlighted part, and it creates this angle right here. And across from this angle, you have a 13. So we write it down. TQS is highlighted here, forming this angle. And across from that is 14. So 13 is less than 14, therefore angle RSQ is less than angle TQS. Let's try number 8 together. JMK, and I'm going to grab a highlighter. JMK, so this angle right here, across from 27. So we're going to put 27. Then you have LMK. LMK. So we're going to create this corner right here. And this corner is across from 28. So we're going to put 28 right there. And now you just compare 27 compared to 28. 27 is less than. Therefore, the angle JMK is less than LMK. In the next video, you're going to practice these skills. So hopefully you watch it.